So, Ishiguro-san will be presenting on the topic of optimization of personal mobility. And with that, I'd like to hand over to you. Please.
Thank you. Okay, hello. This is Satoshi Ishiguro. Maybe it's a very different name from you in Europe and the UK. Ishiguro stands for the black stone, and my name is Satoshi is wisdom. So I'm the black stone of wisdom. Doesn't make sense. Okay, my parents. Okay, let me introduce ourselves. We came from Japan, very near the Toyota City. Do you know the Toyota City? It's named after a little bit famous company. Car manufacturer, yes. And it's in the middle of the Japan islands. And main customers is famous manufacturer Toyota, Yamaha, or part suppliers, Aishin or something. Like, so Panasonic or Honda. Have you ever heard it? Oh, thank you. And HBD has many development projects, and we are designing the car parts, like wire harness, interiors, exterior parts, and doors and door locks, door handles. And moreover, we design not only car parts, but also like medical things and robots. And this is the world's largest skateboard. It's a real one, yes. It's 12 meters long and maneuverable only one person. I designed this for a joke. And we have some additive manufacturing devices like these plastic and metals too. Then why HVD and GIM? Because we are the design company, we don't manufacturing because we don't have, casting or bending of machines. We don't have, and we do want to make the things more efficient. Efficient. Yes, that's it. So we need CA calculation solutions for better design outputs. Because we have courage to design these things and creativity, like me. And GRM has the CAE technology and super smart people came from the CAE, especially Adam Hargreaves, Mr. Thank you, thanks so much. The future of design is not come from the intuition or some big efforts, but come from the high technologies and good vision for the future. So, let me talk about personal mobility. Have you ever heard of personal mobility? Hands up? Good. It comes from kind of bicycles and motorcycles, but we have very, very limited vehicles like bicycles and motorcycles. But we want to have diversity in the traffic, like elderly people or young kids. And HVD has developed and designed these things, like these are Toyota's concept models for the exhibition. And this one too. And iRoad is made really about more than 100 vehicles and the testing in Japan and France. And these are the we call personal mobility, and we made the small, very tiny car, and to make cheaper and affordable and make very faster than normal cars. I want to say, most of our customers or clients called us, hey, can I do it? We don't have money, we don't have time. So I always say, okay, calm down. We have solutions. Thanks for the optimized engineering design. We can offer the very, very good outputs for satisfy the customers like Toyota or Yamaha. And we are doing very good business for them. This is an example of personal mobility. You can see the pictures or like those movies on that miniature models in the other rooms. We call this is an ILE. The project was developed optimized so very light vehicle because the personal mobility is very small, so people want to take it into your room or into the stations or bring them all over the city. So the first priority is to make it lighter, the lightest. So to make the vehicles lighter, we consider three types of manufacturings. No manufacturing constraints and a single casting or two casting to make the footboard. And we start from the design volume. We had to add the footboard to ride the people in a footbed, and we have to have a space of battery space. So the standing load case is 110 kilograms for 3 Gs for the footboard. And we have small tires in the rear area, so rotor twisting load come from the ground. The result is here. We don't have no constraints for the manufacturing. It goes 2.46 kilograms. And single casting, twin casting is not so different in here. During our designing, the project is going on, so we need to recreate the new design for the new parts is coming to us. The start point is the mass was 4.49 kilograms. So we need to reduce the mass. Thanks for the GM technologies, we can reduce so many masses like, this portion, the blue portion is very, redundant, and the red portion is very, dangerous for the fraction. We can think about like rib structures, and we can reduce that thickness of rib structures and the main structures or main thickness. After all, we can reduce about 1.3 kilograms for the structure. Yes, it's a very good conclusion, yes. So the future is we want to make this collaboration is more efficient and more fluently designing and calculations to make the better place, to make the world a better place. Thank you so much. Thanks for listening.
All right then. Any questions on this topic? No? I do.
Okay.
It's less about the engineering. It's more about where do people ride or drive these things? Pavements, roads? Where?
Payments?
On the pavement, so the I-road.
Yes.
I-road is on the road?
Yes.
And the icing example, this is on the pavement. Do you go out of the way?
Out of the way.
Okay, and this mass reduction, was it enough?
Yes.
Yeah?
Very, yes.
Okay.
The former model was about 40 kilograms, and
Yeah.
this one is 30.
30, okay, so 10
Yes.
kilo, the whole...
Yes, whole things, yes.
Right.
Thanks for your technology.
Oh, that's right. It's quite nice. I do absolutely nothing here. Adam and you guys in Japan are doing this. So it's really exciting.
Yes.
Great. Okay, any more questions? No? Great. Well, thank you very much.
Thanks so much.
It's quite interesting. Thank you. Thank you very much.